Hi, this is a video to kick off unit number 3. It is about randomness, sampling, and bias. We've done a lot of work with what to do once we have data, right? We've looked at one variable versus two variable. We've looked at different ways of representing data graphically. But the question is, okay, so let's take a step backwards. How do you get the data? This unit actually has a lot of vocabulary. So I would invite you to think about what are some ways that you have used in the past in other classes that have helped you to learn vocabulary well. The answer to that is flashcards or vocabulary list or made myself a Quizlet. Any of those things could apply. We maybe are not used to thinking of them in math, but I would just point out to you that ways that you've used in other classes can carry over to learning the vocab in this class. This particular unit is not going to feel so much like math to you. It is very much about vocabulary and definitions and logic. All right, so sometimes when I am around young people such as yourself, I hear them say things like, oh, that's so random. What do we mean by that when we say that in our day-to-day speech? Well, I mean, I am old, but I think what the young people mean by, oh, that's so random is, that's so out of the blue, that's so unusual. Well, is that the same thing that mathematicians mean by the word random? Unfortunately not. Okay, so when we talk about randomness in our context of mathematics, it has to do with probability and having the same probability of being selected as any other element within our population. And so bear in mind that a lot of the things that we do in a stats class involve some kind of randomness. We do things like simulations where we might use like colored beads or we might use dice or something like that to simulate an activity among people that isn't really that activity, right? We might flip some coins or something like that to simulate making a decision, for example. And clearly the coin is not deciding anything. We also use surveys. Surveys are great, like they're an opportunity to have people tell their opinion, but we should use randomness in our surveying because if we just say, ask our friends, we might get a biased or a skewed view of what's going on, right? If I ask all of my 50-something book reading, my book club, let's say, like my middle-aged woman book club, if I ask them, ooh, what are some good movies out right now? That probably isn't very representative of the population of all people as a whole, right? Very unlikely to say get the Marvel movies mentioned. I'm just saying it's not that cool of a book club that I'm in, okay? So understand that when we're surveying, we don't want to just ask our friends, we want to ask a representative sample. And the way to do that is through randomness. And then experiments involve randomness because if we are testing, say, a new medication versus an old medication versus no medication, we want to assign the people who are getting those different treatments randomly. Because if, say, we give the most sick people the medication that we think is going to work best, that isn't really trying it across the full spectrum of patients, okay? So understand that simulations, surveys, experiments all hinge on some idea of randomness. And randomness is where all the different entities in the situation have the same probability of being selected. These are some vocabulary words. Remember I said it was vocabulary heavy? Here we go. All right, so I represent this with a Venn diagram. And this entire group here would be the group of people or things that we would call our population. And I say or things because maybe I'm doing a study on corn plants, right? I want to know what makes corn grow the best because I want to make some ethanol or something. So the population is the big group of people or things or corn plants or whatever. And then the sample is a subset of that population. Ideally, that sample is chosen randomly. Not just, ooh, these are the corn plants that are easiest to get to in the field, so they're my sample. No, I should use some kind of random selection to choose my sample if my study is going to be strong. Now, in my study, I am trying to determine something that is true of the population. That thing that is true about the population is what's called a parameter. So it might be, if I'm thinking about that cornfield, it might be what is the average height of a corn plant in this giant field that I have, 150 acres or something, okay? So it might be what is the average height of the corn plants, all of them, okay? But I'm not going to actually measure all of them. I'm going to take my sample, measure the height in the sample, so take that smaller group of corn plants, measure their height, find their average height, and then that will be my statistic. The statistic is something that I actually know a number for, or a value, whereas the parameter is the number that I'm trying to estimate with that statistic. So generally speaking, we don't know the parameter. Now there's some exceptions to that, where we can actually look at the entire population and find values about the entire population, but that is a rare event, okay? So sampling methods, which because of how they were done, how the sampling happened, tend to either over or underestimate certain traits, are said to be biased. So let's go back to my book club. If I use the sampling methodology of I am going to ask friends of mine a question like, what movies do you like? What movie do you think was excellent this year? Because of how I designed my sampling, which was, I'm just going to ask these women that I see on 2 Fridays a month. I'm just going to ask them, okay? If my sampling technique is what leads to this distortion of the data, then that sampling technique is said to be biased. Now, if we are good statisticians, we strive to minimize bias. And sadly, bias is just one of those things. You never fully get rid of it, okay? But you try your hardest to make it as small as possible, because by using randomness, we can minimize our bias, okay? Now, you might be asking, why don't we just ask everyone? Now, I was saying back here on this side that there are times that we can ask everyone. If my population is my extended family, I actually can ask everyone. I have a very small family. A lot of families I have like 1 or 2 kids, 3 is on the large side. So I don't have that many cousins. I don't have that many aunts or uncles. So if I wanted to ask my extended family something, I actually could ask everybody, right? When do you want, or whose house do you think we should go to for Thanksgiving? Is a question I could literally ask everyone. And if you do ask everyone in a population, that is called a census. And you might have heard this word in the news before. So we take a census as the United States, right? The United States government does something that's called the census, and that is where they ask everyone in the country to participate in taking a short survey. And that survey gives some data about the people in the United States. Now, not to go off on a huge tangent, but there's kind of a short form of the census and a long form of the census. And if you are selected to be in the sample that does the long form, you're asked more questions than if you just are asked the short form. Now, you might say, well, why do they do that? Well, first of all, the long form, as the name suggests, is long. And so they don't want to burden people with that much. Furthermore, it would result in a lot of data, and having a lot of data means a lot of statistical work. And by sampling can still give you a good idea of what's happening with the whole population if that sample is chosen randomly. So with the actual United States Census, they ask everyone certain questions. And that's what makes it a census, because they're asked everyone. But there's also a subset that's actually more like sampling, okay? So there are times when it's possible to ask everyone. When we do that, that is called taking a census instead of determining a sample, okay? And we settle for the sample because a lot of times that's enough. So imagine that you're cooking some soup. Okay, here's my pot of soup. Sampling is like taking a taste of the soup. Now, if we want that sample to be representative, we can't just skim across the top of the pot, right? Because then we might get like a lot of the vegetables, not a lot of the broth or something like that. And so if we want to have our taste of the soup be representative of everything that's in the pot, we need to stir the pot. And then as we stir the pot, we need to bring our spoon through all the layers of the soup. That's a representative sample. So I think this is a really good analogy. Randomization is what stirs the soup. And sampling is like getting a taste of the soup. You do not actually have to eat all of the soup to know what the soup tastes like, right? Just get a representative sample tells you what all of the soup tastes like. And that's exactly what's going on in sampling. Okay, now if you turn to the next page of your notes, if you're following along on the PDF, or if you printed it out. These are all different kinds of sampling. Whew. And this is where the vocab gets a little spicy, okay? So there are different kinds of sampling. They all get used in reality. Even the ones that I say are not the best, they do get used at times. And that's because, you have to make some determinations, right? So, like, if any of you have ever babysat, right, or watched, like, your little cousins or something, there might be times when you're like, well, ideally, my cousin would brush his teeth before going to bed, but it turns out he just fell asleep here at 7 o'clock. So am I going to make the concession that his teeth are dirty while he's sleeping, or am I going to wake him up, right? So sometimes things don't go ideally, right? And you make a concession. This is true of types of sampling too. Sometimes it's like, okay, I know this isn't ideal, but I'm making a concession. All right, so the first one is the gold standard. The simple random sample is the attribute that we seek the most. We can have other sampling techniques that are more complicated than this one, but really all of those really good, bigger techniques have simple random sampling at their root, okay? And so a simple random sample is where you use some kind of tool to randomly select. And remember that random means that all numbers have an equal probability of being chosen. Okay, that is the mathematical definition of random selection. Okay, it's not, oh, that's so random. That's not that kind of random. It's the math kind of random. Okay, so there's this beautiful thing called the random numbers table. It, like me, is an invention of the 1970s. And the random numbers table is really cool because it required a computer to be able to be created. And what's neat about it is each digit, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, each digit is there an equal number of times. That in and of itself is not that amazing. But in addition to that, every 2-digit number, so like 66 and 92 and 55. Oh, that was a bad choice of highlighter. I hope you kind of get what I'm doing here, taking 2 numbers at a time. So each 2-digit number is there on the table an equal number of times. And each 3-digit number is there on the table an equal number of times, and so on. And that's what is amazing about it. So because of the equal representation of different blocks of digits, this is randomness, right? Because we said randomness meant that everything had the same likelihood of being chosen. Now, I don't have a full random numbers table here. I just have a chunk of it. And so what I'll show you is if I wanted to do a random selection, and let's say, like with the random rectangles activity, let's say I had things numbered from 0 to 100. Actually, let's say from 1 to 100. Actually, sorry, sometimes my improvising way of thinking is not the best. Let's say from 0 to 99. Sorry about that. Okay, so now notice I wrote 0 as double 0. And the reason for that is if this number has 2 digits, then every number has to have 2 digits. So 0, 1, 0, 2, 0, 3, 0, 4, etc. would be the way that I would label everything in my population. So every element in my population would get a 2-digit label. Much like you have a label with your student ID number, right? That's a label. So everything in the population of 100 things would get a 2-digit label. And then I can pick an arbitrary point on the random numbers table and start reading. 66, you're in. 92, you're in. 55, you're in. 56, you're in, right? And that would be how I would determine what was in my sample. And if I wanted to have a sample of 5, I would just keep reading there. So let me read like more precisely because that was a mess. So, sorry. So 66, 92, 55, 56, and 58 would be the things that I would pick. I'd look through my list and I'd see which element had the 66 on it, and then that person or that corn plant would be in my sample. Okay? Now, if, let's say, I didn't have quite 100 things, let's say this only went up to 60. Okay, so I had 61 elements. 0 to 60 is 61 things, okay? So say that that was my numbering. When I read 66 and 92, that doesn't help me because there aren't things with those numbers. So I would have to keep reading until I got, 39 and 10. And now this would be my sample, right? Because if my numbers only go up to 60, picking things that are over 60, that doesn't work. There isn't a thing with those numbers, okay? So that's the idea of the random numbers table. You can use the calculator to help you pick things randomly. You could put names in a hat and draw pieces of paper out of a hat. That's random as well. Now the next term, and this term is sometimes referred to as an SRS, just by its initials. Now the next thing has those initials, but that's not what we mean by SRS. Stratified random sampling, okay? Stratified means layers. So in a stratified random sample, you break things into little groups, okay? And those little groups or those layers all have something in common. So an example that I like to use in the high school context is, let's say we break people apart by grade level, like seniors, juniors, sophomores, freshmen, right? And then within each of those groups, we pick 3 people. So now my sample has 12 people in it, and we have equal representation from each strata. Cluster sampling is more like we have groups that already pre-exist. So let's think about your breakout groups, right? When I ask you guys to go work in your groups. So I might have breakout groups 1 through 6. And then I might roll a die, and I get group 2 and group 5. Group 2 has 3 people in it. This is group 2, breakout group number 2. And group 5, so a little bit bigger group, it has 4 people in it. Now, all of these people are my sample. All of the people from 2 and all of the people from 5. Okay? These two are commonly confused. Okay, so here is my picture about stratified sampling versus cluster sampling. The first one is stratified sampling. Notice how you grouped by color, right? It could be by color, could be by grade level, could be by anything, okay, but something that makes them match. And then within every single one of those subgroups, you pick a few, okay? Whereas cluster sampling is you have groups that pre-exist. They're not grouped by being alike in some way. They just pre-exist, pre-existing groups. And then you pick all of a couple of those subgroups. That's cluster sampling. So I invite you to draw yourself some kind of note about this, because I'm telling you, this is the thing people mess up on the test. I don't know how to make it more clear than this. Maybe you have ideas. If you have ideas, tell me, because I feel like this picture makes it clear, right? You group by an attribute, you pick a few in each subgroup, versus you have mixed up groups, but you pick all of the subgroups. Okay? So cluster sampling is what's over here on the right. All right, the next couple. I have heard this one called systemic sampling, and I've heard this one called systematic sampling. So I apologize. I really don't know what the right term is, and I use them both now because I've heard them both. But this is the one where you pick every so many. Let me write this differently, actually. Pick every nth item. So if I wanted to stand at the door of the high school and hand out a coupon for getting a discount on going to the spring play, right? And say you have a free ticket to go to the spring play. I might hand that out to every 10th person. That's being systematic or systemic, okay? This sampling is used a lot on assembly lines, right? They don't want to necessarily inspect every pair of jeans that they make, but they are going to inspect every 15th pair and make sure that the pockets and the rivets are all really good, and then move on, okay? So quality control uses this kind of sampling quite a bit. Multi-stage sampling is a term that's just given to combining different kinds of sampling that is on the list. So I don't know, there's not really a definition for that. We don't really need that in our notes. These last two I have stars by because they each are flawed, but they each have uses, if that makes sense. So voluntary response sampling is where you ask, I know, it's amazing, but it sounds like what it means. It's where you ask for volunteers to respond or to participate. And my favorite example of this is this bumper sticker. How's my driving? Right? Now, my family lives up in Minnesota, and so sometimes I find myself driving on 94, 7.5 hours up to see my family, and I pass, or I'm behind a lot of semis, and semis will have this sticker that says, how's my driving, call this number. I never have. And do you know why? Because they're driving fine, right? But if I was cut off by a semi, almost crashed into the semi, I might say to the passengers in my car, hey, pull out your cell phone and call that number and tell them that this driver just totally cut us off. So is this working? And from the perspective of the trucking company, it 100% is. Because they don't actually care to hear all the data about their drivers doing great. They only care about the drivers that are being awful. And so the no news is good news philosophy reigns there. Now, the voluntary response sample is flawed in that if you are just asking people to participate, who is it that's actually going to be compelled to participate? So if I said, hey, I want you guys to tell me how you think class is going, some of you are going to be like, man, I don't want to do that. Some of you might be like, oh, I totally do. And I think the people that are like, oh, I totally do, are the people who either love this class so very much it's their favorite, or they hate this class and they think I suck, right? So voluntary response sampling attracts strong opinions. Because people with mediocre opinions, they're not going to take the time. They're not going to take the time to call in. Convenience sampling is what happens at the mall. Okay, if you remember, like walking around the mall, a lot of the times you see these people with like clipboards. And if you're me, you avoid making eye contact and you walk faster, right? But convenience sampler, the reason that those people exist in a mall is because they figured that's a place to get a lot of people, right? So it's convenient in that they can be in a nice warm place, not exposed to the weather, not having to make a ton of phone calls. and they can still try to get a lot of data. So convenient sampling is called that because it's convenient for the person who's trying to ask questions. However, what's the problem? There are certain people who are never going to participate in this. I would actually consider myself to be one of them. If I'm actually in a mall trying to get errands done, I am not going to answer your survey about cologne. That's just not going to happen, okay? So, and there are people who would never go to the mall. Like my dad never, ever walks into a mall. So you're never going to get representation for certain people who aren't going to go to that location. Okay, so convenient sampling has its flaws. Like a lot of times you'll hear like textbook examples they'll talk about, these people are standing outside the cafeteria and they're surveying people about the quality of the food in the cafeteria. Well, if you really think the cafeteria is the worst, are you even going to go there? Right? So aren't you missing part of the people? I think you are. Okay, so convenient sampling and voluntary response sampling both are flawed in terms of design in general. They have their places where they could be used. Okay, it's important to remember that there's a thing called sampling variability, which means if you did your study once and you got a sample of like 100 people and you look at your statistics, and then you repeated the entire process, got a different sample, different 100 people, your statistics are actually going to be a little bit different, okay? So bear in mind that different samples are going to have slightly different results, okay? They aren't truth, they are just a taste of the pot of soup. These last three terms I really want to emphasize because, especially if you have taken psychology, I know that in that class they introduced some other terms about bias. I literally restrict our attention to just these three. So bias is what comes about from having your study designed poorly, perhaps, right? Or it can come about for other reasons, and these reflect some of the other reasons. Undercoverage is what it sounds like. You are not representing everyone, okay? So if I had a survey and I said I'm going to walk up and down my street and around, Lake Forest, and I'm going to, from 9 o'clock to noon, I'm going to ask people survey questions. That would be undercoverage because there are some people who are literally not home during the daytime hours because they have jobs outside the home, okay? So undercoverage is where you are missing part of the population because of what you are doing in terms of designing the study. Now, non-response is something that happens because of the people in the study. It's not because of the design. Non-response is when people literally do not respond. So I might have my sample picked beautifully. I might have used my random numbers table, and I have a nice list of different households that I'm going to have in my sample, but then there are people who just slam the door in my face, so to speak, okay? So I might have an issue of non-response because there are some people who are choosing not to respond. So even though my sample was picked great, that messes with that randomness. Response bias just means people are lying. So if people are lying, that's like their response is not valid, okay? So this happens a lot when you ask questions that are kind of personal in nature, right? If you ask someone about their drug use or other illicit behaviors, people sometimes lie about that. People can lie on political surveys if they think that the person asking them the question wants them to answer a certain way, and they sense that, they might go ahead and answer that way, even if it isn't true. And that's response bias. Your assignment is doing problem set 3.1, and next class period we'll be doing an in-class assignment. Thanks.